Hey, what's going on, guys? Let's do this problem right here. The question is asking what is the measured volume and pressure of the 10 moles of oxygen gas in a 5-liter container at 30 degrees Celsius. So they are asking for the measured volume and the measured pressure. So let's see how we can find this one. So first of all, to find this one, we need to find the measured pressure. We need to calculate the ideal pressure first, because pressure is this part only, right? This part only gives you the measured pressure, and then you have to calculate this one. What you have to do, you calculate the ideal pressure. Actually, this one is plus right here. So this one is plus, and then if you calculate this is ideal pressure, right? Ideal. And if you calculate this one, this is going to be the total thing, ideal pressure. This one and this one are same thing, and this is the total thing, but we have to find this one. So if we find this one and subtract this one, we will get the measured pressure. So let's calculate the ideal pressure first. To find that one, I am going to use the ideal gas law, that is PV is equal to nRT. So P is equal to nRT divided by V. Here they have provided the mole, so let's list all the values they have given. We have this moles right here, that is 10 mole, and then temperature is 30 degrees Celsius. We have to convert into Kelvin, so we have to add 273 for this one. That will give us 303 Kelvin. And then we have the volume, that is 5 liter, so V is equal to 5 liter, and that's all the information we have, and this is all we are going to apply. So here we are going to apply 10 more. 10 times R is 8.314, and then temperature is 303 Kelvin. 303 divided by 5 liter, and if you calculate this one, this will give you 5,038,284 Pascal, and if you convert this one into ATM, you will get 49.7 ATM. So this is our ideal pressure. So to calculate the measured pressure, I have to calculate this one also. This part right here, I have to calculate that one and subtract from this one to get this measured pressure. So let's calculate that one. Delta P, the pressure change, is equal to AN square divided by V square. So here we have to know the A value. A value, that is for oxygen. We are dealing with oxygen right here. So we have to find the A value, that is 1.36 ATM liter square per mole square. So this is going to be 1.36 ATM liter square per mole square, multiplied by mole square, that is 10 mole. So 10 mole square divided by V square, that is 5 liter square. 5 liter square, and if you calculate this one, this will give you 5.44 ATM. So according to this one right here, we know that ideal pressure PI is equal to P measured plus this delta P. So we are trying to find this one right here. This part is the one the question is asking. So let's rearrange this equation. PM is equal to P ideal minus delta P. So P ideal we already calculated, that is 49.7 ATM. So 49.7 ATM minus this value, delta P, that is 5.44 ATM, and that will give us 44.26 ATM. And this is the answer for this part, this pressure part. But they are also asking for the measured volume. For measured volume, it's a different thing. Measured volume is going to be the ideal volume, because measured volume is the whole thing. So we have the volume right here, that's 5 liter, that is V. So we have to find NB. in order to find the ideal volume. So let's calculate the NB. So delta V is equal to NB, volume change is equal to NB, and we have the mole, that is 10 mole multiplied by B. B is this value. So we are dealing with the oxygen, so this is the value we are going to apply. So this value is 0.0318, and if you multiply this one by 10, you will get 0.318 liter. So we have this value right now, and V ideal, that's what we are trying to find. V ideal is equal to 5 liter minus this one, 0.318 liter, and that one gives us 4.682 liter, and that is the measured volume. Ideal volume, same thing. Also we can say Vm equal to Vm, and that is this value, and that's the answer for this part. And that's how we do this kind of problems. I hope you guys like this video. See you next time.